Okay, if I gave you a test on yesterday's stuff, this would be some of the topics that you should have learned yesterday. Make sure you got them. Let's say that I give you this, y equals what goes here and here and here in the general form of a quadratic. Don't say it, write it. Write it down on paper. That was one of the equations you needed to memorize. Next, x equals something over something, and that was part of the vertex. The x of the vertex. It goes here. What was that little formula? That's the second one I want you to try to recall from yesterday. X equals something over something. Paper. All right. And then, using those two things, take this equation, y equals a negative, throwing in a negative there, x squared plus 10x plus 2, and write me, using this, write me an equation that looks like this, vertex form of that equation. Your first step again is to find this part. How many of you knew that this part was negative b over 2a? Raise your hand if you had that right. Okay, good. Use that now to figure out what the x coordinate is of your vertex. Then go back, plug it in, figure out what y has to be. Here we go. So you should have said negative 10 over 2a's, and a is something this time. A is negative 1. So 2 times negative 1 would make negative 2. So then that would come out to positive 5. Raise your hand if you had that part right. Okay, good. I bet some of you messed up the negative, but that's okay. So then if x is 5, we have 5 comma something, and then we got to figure out what? Well, we go back and put 5 in right here and here. And we get negative 25 and positive 50. Have you noticed that there's always that little deal where it's like twice as big as it? And I don't know if you've noticed that pattern, but it always works that way, these first two. Anyway, not necessarily always, but often. All the ones I gave you yesterday. So then we'd have 25. 25 plus 2 is 27. Final answer is this is 27. Now, I found the vertex 5 comma 27. Raise your hand if you got the same thing as I did. Okay, good. But do you actually have the right equation? The final answer is y equals, and instead of a, I know what a is. A is right here. It's negative 1, or just negative, because that's, look at, that's a, that's b, and that's c, right? Remember that? So a is negative 1, so I know it's negative. And then I have x, and then this next part is minus whatever the x is, which is 5. And then squared, and then plus 27. Why isn't this positive 5 and positive 27? The thing on the inside is always opposite of what you would think. So would anybody have gotten that one right? Good, then you've already learned, like seriously, well, one more thing they'd asked to make this like half the stuff on the test would be, what is the axis of symmetry? 5 is wrong. X equals 5, there you go. I'm pushing that because you are going to hopefully not make that mistake on the test, because if you say the axis of symmetry is just 5, I will have to mark it wrong. This is an equation, and that's what you're looking for. An axis of symmetry is a line, so we need an equation of a line. All right, now, what's new for today? Thankfully, not that much. Today, I get to just clarify for you what linear regression versus quadratic regression is. You know, we keep on moving things up, right? And yet, first, you just needed to know how to take 2 points and make a line out of those. We still have some review questions like that. And then you needed to know this formula, y minus y1. That was a long time ago. Then the next step we moved up to is doing a linear regression. That's where we give you some data, like 0, 1, 2, 3, and let's say this is how many possum that you got on your last hunt. And let's say you got 4 here, 5 here, 6 here, 7 here. And if I took this and put this in the calculator, do you remember that lin-reg thing? Well, can you imagine that the next thing down on the list in the calculator is quadreg? What do you think that means? Quadratic regression. And all it means, it's the exact same kind of a process, is that the data isn't just linear. The data we will give you is quadratic data, meaning that the data, instead of just making a straight line like this, the data we would give you would go like this. It makes a curve, like quadratic kind of, like really hot, really fast increases in numbers. So that you don't have to worry about that, but we're going to give you the data, and the data will be quadratic data, and then you'll have to figure out the equation for it. So before, the lin-reg would say something like y equals ax plus b. It's just telling you what form it's giving the equation in, where a equals 4.067, and then b was like negative 108.693 or whatever. And that was giving you an equation like this. That's linear, right? It's like y equals mx plus b form. This is the slope, that's the y-intercept. Well, now, let's see what it does when we give you some quadratic data. So everybody right now, grab your graphing calculator. If you haven't got one, borrow one of mine. These will be very necessary today. I have several. Give me something of value, like a cell phone or a shoe, and I'll gladly give you a calc. Yes. All right, so we now have the calculator in ready position. We got it under stat, we got it under edit, and we've cleared off our L1 and L2 and ready to go. Does anybody not have L1 and L2? All right, add 2 people. I'm going to fix yours real quick. Okay, I'm back with you. So let's enter some data here. I'm going to keep it simple. I'm going to keep it simple and just put in 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. And then I'm going to put in some data that you would know would be quadratic. We're going to just put in the classic parabola, which would mean x is 1, y would be what? 1, 1 goes together. In other words, if I put in 1 and I square it, I get 1. Then if I put in 2 and I square it, 4. What comes next? 9. And then what? 16. Okay, except then this last one, go up and make it, instead of 16, we're just going to show you that data doesn't have to be perfect. Let's make it 17. Okay, so the data isn't exactly quadratic, but it's really close to exactly quadratic. Okay, now we're going to go into stat and calculate. Remember how it's over one menu, calculate. And now if you go down there, you see quadreg. All right. Not lin-reg, that would be if it's linear. We do have one problem of review on the worksheet like that. Quadreg. And now, what does it want me to tell it next? Where the data is coming from. L1, comma, L2, it's right above the 2, comma, and then what do I put here now? Y1, and that's under vars, yvars, function y1. That was again under vars, yvars, functions. Okay, now if I hit enter, it tells you, instead of y equals mx plus b, it tells you y equals ax squared plus bx plus c, where a is 1.25, b is negative 0.95, and c is 0.75. See, that would have been a perfect normal quadratic if I hadn't screwed up that one number and made it a 17 instead of a 16. So that made us have a little bit of decimals in here, but it's not too bad. Okay, so now if you actually write out your equation, it would be y equals 1.25x squared plus, or actually in this case minus 0.95 x, and then plus 0.75. Okay, now how do you use that? Once again, they will give you time, or they will give you, in this case, my example was about possums. So if I were going to get x and y, this is x, L1 is your x, and L2 is your y. And so if they gave me, well, when is Billy Bob going to hit 100 possum? You can put that in for what, y or x? Y. Possum would be the y. X is always time, okay? Or we might say, on day 9, how many possum would Billy Bob get? Okay, so that would be an x. Well, it depends. If they've given me an equation like this, y equals 1.25 x squared minus 0.95x plus, what was the third number? 0.75, thank you. Then if they tell me an x, I'm going to put it here and solve for y. If they're going to give me a y, then I got to put it here and solve for x. And some people might be like, how on earth am I supposed to solve for that? You've got a graphing calculator, right? So couldn't you graph this one? Like, let's say they told me that the time was 10. Or sorry, the possum number of possum. Some people are talking, it's distracting me. The number of possum was 10. Then I put that here, and I would now have this equation, which, don't forget, you can graph both sides and see where they cross. And how would I have this one in my equation? It was already in your calculator. Where is it right now? It's y1 already. So if you wanted to put in the other equation, you're just going to have to put in this side, which is y equals 10. And that can be your y sub 2. And then you see where they cross. Okay, remember that to find an answer to one of these, you just are graphing both sides and see where they cross. All right, and do you remember that other method? Like, let's say we wanted to say x was certain thing. Okay, let's get this up on the calculator and show you what I'm talking about. Now that I've got this done, and it's already under y, it's right there, how do I tell it that x is like 12? It was there automatically because I said L1, comma L2, comma Y1. It automatically puts your answer on Y1. Okay, so now my equation's in there under Y1. Well, there's two ways. You could either go to graph, and if I hit graph, here's my graph, and then I could ask it about an x value. Like, let's say I wanted to know x was equal to 10. Then you go to second, calculate a value, number 1. Now, the only trick to this is, I think, if you ask it about something that's off of the screen, it won't be able to handle it. So right now, I know my x's only go out to, well, if I go to like x equals 5 even, it's going to be off the screen. I'm going to hit x equals 5 and see if it can handle it. Oh, okay, I guess it can handle it. Awesome. It's, even though it's off the screen, it tells me when x is y, y is 27.5. All right? So let's do that right now. I'm going to give you a situation now. I'm going to give you that the time is day 9. I'd like you to tell me on day 9 how many possum is Billy Bob going to get. That's under second calculate. Second calculate calculates that button up there, the red, leaving red. All right, value, and on day 9. So I hit 9, I hit enter, and there it tells me it's going to be 93.45. Raise your hand if you got the same thing as I did. Okay, good. Now let's change it up and say instead of on day 9, instead it's going to be when is Billy Bob going to hit 105 possum on his trip. Okay, how do we get this to 105? Well, this one I would do with graphing both sides and see where they cross. I have my first line right there. And my y, that I was just told a y number, the number of possum was 105. I'm going to put in 105 here. And how can I see where these two lines cross? When I hit graph, unfortunately, I'm not going to see that line at 105, am I? Because my graph only goes up to 10. So I have to somehow tell it to go out far enough so I can see that. I would recommend you just go to the window, and we want y to go up higher. And instead of y maxing out, in this case, mine's only going to 6. I'm going to make it go to 120, for instance. And I just hit graph, and now I see, can I see these, my two lines crossing or not? And it looks like it's going to be really close. Oh, not quite. So I need to go a little further on the x. So you go to your window, make your x max be like 12 or something, bigger than 9. Graph again, see where they cross. If you can see where they cross, do you remember what to do now? Intersect, yes. Second, calculate. Intersect. Intersect is number 5. And then it says first curve. When there's only 2 things graphed, you can hit enter and enter for the first 2 questions. But the third one where it says guess, there are 2 places it crosses, right? We got to arrow over and get somewhat close to where these 2 cross. And you know what? That's good enough. It's closer than any other place they cross. So you don't have to get perfect. Hit enter. It jumps to that spot where they cross. And it says they cross at 9.52 and 105. What does that mean again? 105 possum, and what the heck is 9.52? 9.52 days. Now, that means that Billy Bob really won't get 105 possums on 9.52 days, because he only goes out on day 9 and day 10. On day 9, he wouldn't have gotten enough possum then. So you'd have to say 9.5, what's the next closest thing? 10. It would take Billy Bob on the 10th day, he'd get actually more than 105 possum. All right, so it's not incredibly hard because you get to use the calculator, but you got to know how to do these things, how to like manipulate that. So I'm going to give you some time then. You've got your calculator and you've got time, and here is your worksheet. One last thought, since it's so easy today, remember that 2-minute teacher version, what did I give you the other day? Not top 20, what version does it say on top? Version 8. Yeah, it's okay, because some of these are my kids. If you're in service class, version 8, we're working on that in Precalc. So if you have questions about that, ask me today, because that's due tomorrow. Okay, so you've got time to do it today too, because today's worksheet's so easy. All right, so make sure you are getting your 2-minute teacher thing done, the top 20, version 8. Get that into me by tomorrow if you're in service class.